runs in the same fundamentals. Huge shout out to those that came before us. There's a lot of rehashed material here from other presentations, and you should definitely check the reference work. And then we'll talk about our experiences and some things we've done uniquely with this data and data points. So encryption is widespread. It's well known that people are, that the use of encryption has increased throughout the internet. This is, you see charts like this all over the internet from Mozilla and Cisco basically showing not only has encryption increased used, but also malware's adoption of encryption has been used. In our realities, we see anywhere from 50% to 60% of our customer data. We're a SaaS, so we get to see all this, is mostly over SSL, specifically in web protocols. And we've ran into a number of actors who use a wide variety of encryption. So at this point, no one here is surprised. Everyone's like, yeah, duh, this is a well-known fact. But the funny part about that is encryption being used has been used as an argument for just disregarding network detection altogether. Literally been in conversations with well-known researchers who are like, well, if they're using SSL, why do you even bother sniffing the network? Why do you even bother looking? Which is appalling to me. I mean, it's just mind-blowing because there are a lot of detection opportunities even on top of encryption. So first, I want to start by going through how bad guys use encryption. One of the most simple ways, and one that's been around for decades, is the idea of just using self-signed certs. So for anyone who doesn't know, a self-signed cert is where an attacker creates a cryptographic certificate that's not signed or otherwise trusted by any notable authority. They can completely create these in a couple seconds on a Linux command line, and they just purely use it to get encrypted traffic. So again, no established trust in this certificate, just using it for encryption. And most people, like any red teamers in the room, hands raised? Yeah, we got some. Like you would be like, do people actually still do this? Like, is this really a thing? And the fact is, yes. Last week, we pulled a piece of malware or the config, pulled out the IP address, and when we went and go use internet scan data to look at that IP, you can see on the right, self-signed cert. And this self-signed cert is pretending to be Adobe Acrobat Reader. Like, definitely still a thing. Bad guys like to pretend they're different people. The next level up is attackers using legitimate certificates. So with the rise of low-cost free hosting or certificate providers, we've seen a surge in legitimate criminal and threat activity using legitimate certs. So what does this look like? Basically, you go out to Let's Encrypt, Komodo, or any number of legitimate certificate providers that are actually doing a good service by helping people secure their websites or at least gain privacy over the traffic to their websites. But there is very little validation. So many people assume that SSL equals trust, and that's not the case. Like, you have to understand the levels of trust that are involved with certificate validation. So in this left-hand config, you can see another IP address. This is from last week. Fresh new adversary infrastructure stood up on the internet, this IP address. And on the right-hand side, you can see it's using a Let's Encrypt certificate pretending to be a CDN. So bad guys are using this, registering legitimate certificates. Then we get a little bit more fancy. Adversaries using legitimate services and domain fronting. Essentially, the way this works is they register an account on a legitimate service. This could be anything ranging from social media profiles to emails to CDNs, and they redirect or otherwise bin their malware traffic through it. So many people have probably heard of domain fronting. We've seen instances where bad guys are using Google Drive for command and control through sheets. So literally, they're pasting a command in a sheet, and their malware is pulling that command and exfilling data via the sheet. It all kind of looks the same. Trusted third party, that is being an intermediary broker for your malware. And so the really big benefit here is that if there is a tap or a defender listening in the corporate network, they're going to only see the SSL traffic destined and signed by certificates for that third party. So it gets extremely hard at this point to distinguish legitimate and illegitimate. So let's go into Fingerprinting 101. So SSL TLS fingerprinting. There's been a long history here. So dating back to 2009, there's white papers and blogs by a guy named Ivan Ristic, who was with the SSL Labs project, where he hypothesized and did some initial research into the idea of fingerprinting the actual application. So rather than just looking at certificates, is there some way by looking at network traffic that we can say this process or this entity made this connection. And it was some of the earliest research into this, and it grew over the years. Every couple of years, there'd be another research area here and an advancement. Up until in 2017, there's a project named JA3 that was released and gained widespread popularity within the industry, both defensive and offensive knowledge-wise. So what do you actually see? So if I'm a network forensics nerd, I naturally jump to, so it's easy to say it's encrypted, you can't see anything, but is that actually true? Have you looked? Have you ran Wireshark and looked at the traffic? And if you did, you'd realize that's not actually all that true. There's a whole protocol exchange that occurs well before the encrypted traffic starts happening that is mostly plain text. And plain text either in legitimately plain text strings like ASCII, all the way ranging to a well-known structure of metadata or details about the protocol that are important. So the client always begins the negotiations with what's called a client hello. We're going to go into that a little bit more later. The server then responds with the accepted negotiation called a server hello. And then they exchange certificates, and they exchange cipher suites, and they do a whole bunch of like back and forth chatter before saying, okay, we're done talking in plain text. Let's go blackout. Let's go encrypted. And that's all the application traffic. So that all your application level traffic is then protected. So what are these hello messages, and why do they matter? So the hello messages are the start of the exchange and agreement over what crypto protocols are going to be used. So the client will announce a list, or it'll announce a version and a list of cipher suites as well as extensions that it will use or accept. So this will be a longer list, and it generally is just like basically imagine two friends talking together and one friend saying, hey man, do you speak Spanish? And the other friend says, yeah, I speak Spanish, and then you start speaking Spanish. That's essentially what's going on here. The client is saying, I accept these cryptographic protocols. The server responds by saying, yeah, cool, let's use this protocol, and then application traffic begins. It's important to note out, so the picture on the right is an example client hello from PowerShell Empire. There are a number of specific fields in here that are fun. The specific SSL versions in plain text, the cipher suites, which is a whole list of all the different crypto ciphers is in plain text, and a number of all the extensions, including an extension in at least TLS 1.2 called server name, which includes the name of the server that it's starting to communicate with. And so think of like a DNS host name. So we talked about this a little bit. In 2017, there was something called JA3 and JA3s released. Who has heard of JA3, JA3s? All right, yay, good audience for this. Basically, JA3 is the concept of picking out all of the cryptographic things that are exchanged and hashing it. And the reason this is important is because the specific cryptographic exchanges that are chosen at the software layer. So it's code. It's however the SSL call is made is what actually defines what crypto is going to be used. So I, as an application programmer, can say, I want my application to use 1.2, 1.1, or nothing, and it will default to whatever the application stack's set to use. And so if I focus exclusively on understanding what's going on with the crypto negotiations, in theory, I'm focused exclusively on how the application is making the decision. So very specifically, JA3, the client portion, is the TLS version, the ciphers, the extension, the ecliptic curves, ecliptic point formats, all put in an ASCII string and then MD5'd into a hash. So it's a hash that is supposed to represent a unique application. The JA3s, the server, is the MD5 of the TLS version, the cipher, and the extensions. A smaller list because of what's available and how the negotiation works. So you can see this example. Essentially, this is literally what would happen. You would compute all of these numbers separated by dashes and commas and MD5 it. So if you've ever wondered what's happening under the hood of your bro parser or Wireshark, however you're seeing this data, it's not too magical. It's taking a bunch of hex constants and values and MD5ing it into a hash. All right, so you can see that's where the points get pulled from. Literally, you can map a client hello directly to a JA3. Pretty simple. So let's think back to all of our examples how threats work. So we talked about self-signed certs, let's encrypt, and domain fronting. These are the JA3 and JA3s's specifically for these different threats. So starting with self-signed cert, I basically ran a PowerShell empire calling out to, I think it was an Ubuntu 18 box out on VPS, and I exchanged a whole bunch of malware traffic. I did the initial staging, and then I let it beacon for a while, interacted with it. Purely as an example, I know Empire's dead for what it's everyone's worth, but this is a representative example here. And so let's start with self-signed. All these values equate to a JA3 and a JA3s hash. I did this against all three. You'll note here that the self-signed, the JA3 and JA3s match both on the legitimate cert and the illegitimate cert. So what that essentially means is certificates don't play a factor here, IP addresses don't play a factor here. We were able to identify an application. So irrespective of where it was hosted, what type of certificate we used, or anything of the matter, they match. So in theory, maybe we're finding PowerShell Empire in the associated server. And the second one, the last one's really particularly interesting because I hear a lot of people talking about how do we identify domain fronting, how do we detect it at the network level, and this shows a little bit of hope. Even in the domain fronting example, our JA3 matches exactly. And that would be because it's the same client, the same application, making the connection in the same way. Now you'll note that the JA3s in domain fronting is completely different, which if we recall what we talked about in domain fronting makes complete sense because we're not talking directly to our server, we're talking through an intermediary which is acting as our connection. So the server in domain fronting is in fact different, which our JA3 and JA3s validates. One more example I really like, another one I've seen a lot of people talk about, it's undetectable, which is my favorite word as a blue teamer, is DNS over HTTPS. Everyone's been very scared of this. Basically, what if we lose visibility? What if I take my DNS rats, POSH-C2 or Empire, Cobalt Strike, or Meterpreter, and just pipe it over HTTPS? So now they can't even see all my long DNS magic. It's now encrypted. Well, again, if you start using HTTPS, SSL, you now have a JA3 and JA3s hash, or just generically a fingerprint, and that fingerprint is useful. So I ran Godot, which is a particular DNS over HTTPS proof of concept tool. Ran it on Windows x64. I called out to Google and Cloudflare and used some of the common providers. And no matter where I called out to, the JA3 was always the same. So this is no different than any other legitimate traffic C2. And in this particular case, it was really funny, is this hash was 100% unique across our entire data set. I'm talking years of network data from multiple large corporations. And it was because this is some unique Go library, which pretty much no one had been using in our data set ever. And so Go stood out like a sore thumb here, and it actually proved as a really valid and useful JA3 indicator. The last one I want to talk about or and cover is something called Cisco Joy. So in I think it was 2019, Cisco released a package called Cisco Joy. And Cisco Joy is another SSL TLS fingerprinting project. It builds upon a lot of the previous research, including JA3 and JA3s. What was interesting here is a couple aspects. One, their hash or their fingerprints they use are not hashes. They're actually reversible values. They're kind of compressed in a way. And so that when you look at the indicator, if you only collect the indicator, you can go back to understand how the indicator was derived, unlike a hash, which is a one-way function. Another neat aspect here is they went in depth talking about how they correlated endpoint data with network data to enrich JA3s with process information. So rather than just trying to stare at a fingerprint and wonder, what does this fingerprint represent? They actually pulled all the process information from their endpoints and were able to correlate it. So then you could start building a library of fingerprints to executable names or processes, at least, that caused them. In this data set, there were 1,500 unique fingerprints, which were associated with about 2,400 unique process names for a total of around just shy of 13,000 hashes, process hashes. And this was a really interesting thing that drove some of our additional research later on. Anyone seen the No Easy Breach talk by the Mandiant FireEye folks? This is a fantastic talk if you haven't. I'd highly recommend it. Basically, it details their year-long IR engagement against APT29 and all the different creative ways that they had to battle the state-sponsored actor. And what was really interesting to me is if you watch the Twitter exchanges on it too, they actually used a primitive form of SSL and TLS fingerprinting as a way to track this actor when they would roll their malware. So they had basically built like a little in-house version of SSL fingerprinting, and were tracking the actor across the enterprise despite changes in the tool set, despite rolling infrastructure, using this method. And so when I saw this, it definitely inspired motivation to keep researching here as a potentially valid way.
So let's talk about the nuances of fingerprinting. Like, is it really that easy? And obviously, we already said there's no silver bullet, so it's not. But just to get deeper into that, you know, the first question that a lot of people had from this is, can we just blacklist these fingerprints? And no, you really can't. And here's, you know, a great example. The SSL abuse list here has a bunch of JA3 fingerprints that have come from confirmed malware executions. So the example here is TrickBot. And so I took the JA3 fingerprint from the database, searched against all of our data, and certainly found a few legitimate cases, which are on the top of the list there. But down at the bottom, there's actually a WhatsApp client running from a Windows phone. Surprising to find a Windows phone in 2019, but that's a legitimate device. And that's, you know, a legitimate SSL cert to the WhatsApp server, as well as, you know, confirmed WhatsApp IP space.
Yes, this was not TrickBot using WhatsApp. This was legitimately WhatsApp traffic.
So can't just blacklist straight up on the JA3, unfortunately. But further, what does a fingerprint really tell you? Justin already mentioned that it, you know, covers the various parts of the hello handshake. And really, those fingerprints line up to an application, or in some cases, more like a library or the API that's in use. So we took, you know, a bunch of cases from stock Windows machines, and, you know, there will be like 5 or 6 JA3 fingerprints from fresh out of the box Windows. I was a little surprised that IE and Edge overlap. Maybe that's just because I'm ignorant about about what Edge actually works like. But on Windows 10, IE and Edge both have the same fingerprint. Then PowerShell has a separate fingerprint, which is actually also shared with the background intelligent transfer service. And the Windows scripting host has yet another fingerprint. So these fingerprints are all from the same machine, just different ways of, you know, accessing SSL. So he mentioned JA3s earlier, and really this is better in pairs. If you have a JA3, you know approximately what that client might be, but the same client JA3 will always map to one server JA3s. And a different client JA3 will always map to a different server JA3s, because that's how the SSL handshake works. So in this case, the graph above here shows our fingerprint for, I think this was another TrickBot case, where the client JA3 is shared across a bunch of different things. But paired with the JA3s for the actual confirmed TrickBot servers, there's really only a few results. So it cuts down on the noise, and you know those are legitimate TrickBot cases.
And thinking very logically, if you imagine like let's say you're investigating a PowerShell or Python empire talking to the internet over command and control. If you're just looking at JA3, you're just looking for PowerShell in your environment, which is going to be a lot. Here to tell you, if you've ever seen a real corporate environment, you would think that would be a good indicator, but in reality, it's trash. But if you look at the JA3 and JA3s, you're not just looking for PowerShell. You're looking for PowerShell talking to a very specific Python lib and very specific Linux flavors that tend to be used by red team folks or adversaries. And so, again, it just narrows the potential for collisions when you start talking about these things in indicator pairs, and that's how you look at it.
And the same thing is true for Python clients. I did this search trying to find Python and Empire cases, but as mentioned, Empire is kind of dead. Not a lot of live Empire, at least among our clients at the moment. So the Python JA3 produced tons and tons of hits. Found all kind of one-off Python scripts that query different APIs and stuff, and that's not super interesting. So overall, over 2 months for one, we called it a representative customer. They had a stable environment, good number of devices. They had 25,000 unique JA3s over a 60-day period, roughly. And over each individual day, there's kind of up to 6,000 active. Not a whole lot new, but there's kind of a long tail here, is kind of the message of this. There's lots of unique JA3s, and if you're just looking at the fingerprints, you've got a lot of data to look through.
And when you said not a whole lot new, it ranges anywhere from 10 or 12 to, I mean, there were days where we would see 1,000 plus new JA3s that we had never observed in that 2-month data set. So it definitely varied, but I actually consider that potentially like, it's not a lot new at what it could be. It's significantly downboiled from just the amount of network traffic we're seeing in bulk. But it's still a lot to track. If you're a threat intel guy, it's a lot of magically new indicators that you have to worry about, and that's only 2 months in one customer. This data grows significantly when you look across our base.
Yeah, if you try.
We'll get into that, yeah. Do you know about number of devices or throughput?
Off the top of my head.
It's usually for throughput-wise, we're monitoring multiple gigabits of throughput traffic. And devices, man, that ranges really drastically. I think this data is derived from a customer that's on the scale of thousands, but not tens of thousands of devices. So, rough wiggly numbers for you. We actually surveyed this across all our customers, and this was kind of like what I would say we felt we're not statisticians. It was statistically representative enough for us to show. We felt good. HackerCon, not MathCon, luckily.
Yeah, it's not cameras today. So the design spec that the guys at Salesforce put out was that the fingerprint must fit in a tweet. It's got to be something that can be easily shared, but like anything that's on Twitter, there's not a lot of context you can fit into 280 characters. So it loses a lot of information that might be helpful for defenders to hunt or to spot, unique and interesting fingerprints. There's a few examples here that are more or less relevant, but the SSL ping scanner is one that has a few different aspects that make it look unique. First of all, it's longer than the average JA3 fingerprint, I'd say. On top of that, the strictly incrementing order of the cipher suites is very unusual. The second example of the trick bot, its cipher suite list is much more typical, where it has a mapping basically of stronger cipher suites to less strong cipher suites. But then the T-bot, sorry, not trick bot, the T-bot example then, in its case, it has, again, a strictly incrementing list of elliptic curve points. So that one stands out as well, because almost none of the legit ones have either that many elliptic curve options, or they're not ordered in such a way. And then the two Dridex examples are both very short for a JA3. So all of this context would be lost if you just had a 32-character MD5 hash. But with this, if you're just scanning the data, doing manual hunting, these things will stand out much more. So these, it's less usable for their requirements of being able to tweet, but it's much easier for an analyst to identify. And again, the Cisco Joy fingerprints, they keep all of this context, although it's all in hex, so it's slightly different. But you have the context over a single fingerprint, or a single hash, I should say, which is slightly more useful. And as mentioned before, actually, did you mention that? some of this can actually be configurable. So I don't know if the code is very visible to everyone in the back, but this is a basic PowerShell modification of the SSL handshake and specifies, in this case, just which SSL version we're looking at. You can go deeper and specify cipher suites and stuff. But in this case, just changing the SSL version completely changes the fingerprint. And this is something you can very easily add to any of the PowerShell.
And just make it round robin, or randomly change every callback, or you know, then if people are purely looking at JA3 from a blacklist approach, good luck hitting that blacklist. I would add, as a former red teamer, I always, you know, I thought I was super clever, like, ooh, I'm being evasive, like I'm dodging how everyone's looking at this. By being evasive, you are also sticking out. And so, like, you know, if you set yourself to like SSL v3 with like every cipher suite on the planet in your magic configuration, you might look worse than if you just looked like Empire, as far as like you know, people who are doing analysis or analytics-based approaches to this. So I would say if you're going to do this in practice, like use some creativity and logic into it, into how you can avoid the fingerprint but not make your own in a unique way. So really what we wanted to get into after covering the basics was, what was our journey like doing this? And like, you know, over the past couple years, how have we seen this grow and really put this to practice? I can tell you, I was one of the first people when this came out that I was like, we must do this now. Like, this is, you know, super cool. You know, I had known about SSL fingerprinting, but it really wasn't packaged and well supported in a lot of tools. It was kind of, it felt proprietary. Like, a lot of vendors were doing it, but there was not a lot of open source. And so when I saw it, you know, I was hyped, ready to go, and wanted to dive right in. And went off and started, you know, using Empire and Cobalt Strike and Metasploit and calculating all their hashes across all the OS versions and architectures and possible server versions, and starting to build a list. And then when I started to use it, I was a little bit dismayed. And so what I found myself falling back to after about 6 months of initial research was, well, it's not really good for detection. And I'm going to caveat that with, like, I learned later some ideas. But at that point, it's not really good for detection. But where it has been really successful for us initially was just post-compromise. So forensics. We find some evil. We find what JA3 that evil is, and then we pivot across our data to find other cases of that evil. And so, very real-world story. Working against a red team who had written red team, thankfully not real adversary, but not illegitimate adversary, I should say. They were using a custom little Python script in an environment, and so we saw the C2 traffic from this Python script out to a host. Let's say the host was evil.evil over SSL, and it was using let's encrypt cert, and we found it using just like SSL artifacts. And then we were like, well, it's only like one host talking to one server. Like, this can't be that well scoped. Like, I'm sure they're elsewhere. Usually when we find red teams, like, we find one thing and then discoveries explode. So we decided to pivot on JA3, and we actually found the same thing using Azure CDN as a domain front. And so same tool that we just pivoted on the JA3, which there were collisions, and we certainly had a lot of work to investigate and work through those collisions. But it did lead to successful forensic discovery. And usually by the time you've reached forensics, you're willing to sort through collisions because there's an incident, and you want to make sure you run it to ground. Whereas prior to incident, you might not be willing to sort through 10,000 collisions. That's not an acceptable amount of work value payoff. I'll note that this has been really like a personal narrative, I would say. Like, I've felt that the post-compromise hunting piece has been particularly successful when dealing with like the scripting language backdoors, because it's just a quick way to down select on the traffic we're looking at to only looking at things from likely the scripting hosts of some kind. And while I said there's a lot of it, you generally see a lot of legitimate, and then things that stick out as pretty illegitimate. So again, the most often way we found this useful right out the bat, post-compromise hunting. Just pivot on it like it's any other indicator. Nothing particularly special about predicting the application, other than there's a link or association between the events. Fun fact, the sandboxes are starting to adopt JA3 and JA3s, which is really, really helpful. As a blue teamer, one of the challenges is taking a known tool and trying to find all the possible fingerprints for it. Like, I am not a DevOps guy. I'm less than hip in the blue team space. Like my version of this is literally boot and run like 7 concurrent VMs across OS stacks and architectures, and like run the thing in each and do Wireshark and then run a script. Like our research ops guys like giggle at me and make jokes. But like you could DevOps this for all the spin up and automation capability, or you could just use a sandbox, which is built to do just that. And they already have this data point. Definitely,
Some of them.
yeah, some of them. Definitely a call out to the hatching IO. Really awesome to see the JA3 in there, and I believe that one is doing JA3s soon.
Yeah, I talked to Jurian about the JA3s usability, and I think as of Friday, Triage has JA3s enabled.
Yeah, so that's really helpful again because JA3 is kind of a tough indicator on its own. And in VirusTotal JujuBox, they have the JA3 right in the UI there. It's a little bit buried, but you can find it, and it can be really useful for doing this post-compromise work or generating these ahead of time for kind of a context list.
And that's the VirusTotal JujuBox. They have a few different sandbox options if you're familiar with their behavioral reports. So it's not every report is going to have that, but if you find it, they will have JA3.
So dialing back to the why are we here, we got here because over this time, working with other researchers, talking to customers, working with corporations who had heard of this technology, they think it's just so easy to leverage an application fingerprint for pure detection. And so obviously that's a goal. Like we don't want to stop at we have to find evil some other way and then use this. We want to use this unique advancement in network forensics for detection. And so our hypothesis here was we could use this fingerprint in some way, probably procedural detection, not quite like, or tool detection, to find unknown threats, the sexiness. Like we can find the unknown, the known unknowns. And here we're going to kind of assume a clean fingerprint or one with context but has a lot of collisions. Like it's either not previously known or it's at every customer environment we have, and therefore it's not particularly useful with the fingerprint alone. And when I started down this road, it's easy to like drop the mic and say, here we go, and then you say like, okay, where do I actually start? Like, what's the process for this look like? And it looks like pretty standard, what you would call hunt processes, depending on what you call hunt. And so I started by just like, let's look at all the data sources that are available out in the public spaces to get me context. Like the first thing I need is I want to pull all these JA3s and I want to understand what do we know about them already? Like that I don't have to go do proprietary research in. So there's a bunch out there and it continues to grow, I would say. This list is, you can Google and find a lot of offshoots, but these are the 3 that we found to be like, they contain a bulk and they've been useful. The first one is JA3er. It's one of the newest ones. And the fun part about this is when you visit it, they tell you your own JA3, which is always enjoyable. But they also, they provide a downloadable JSON list of every JA3 they've seen and corresponds to the user agents they've seen it from. And basically, they're generating this by having people visit their website. And so it's really good for browser JA3s. It's crowdsourced, and it stays up to date automatically, which is always a plus. It's not like a human running malware and like copy-pasting JA3s to a file and pushing it on GitHub, because that introduces lots of delays. There's the Trizal NSM, and they were one of the earliest guys to kind of explore JA3s. They initially did a conversion of the original fingerprint TLS work from like 2010 or 12, I think. And they converted all of the known prints to JA3s and then added some of their own research and work in there, which was really great. And then there's the SSL blacklist. For those who don't know, the obfuscate SSL guys, they basically run all this crimeware and known malware, and they generate IPs and data for you. They're also generating JA3s now from all of this. So you can go there and see like TrickBot, JA3s, and that's where we obviously use that list. What I found interesting after this initial study, so like step 1, enrich all the data. Great, fantastic. But in one day across our entire environment, so we showed you data before. This is one day, one sample day across our entire customer environment. We had 30,000 hashes. And so of the 30,000 hashes, enriching with this list, it left 97% that we knew nothing about. So like despite the largest public bases of known, there's still a whole lot of unknown that we found in our customer base. And so after this, I wouldn't say discouraged, maybe motivated and a little bit knowing that this was going to be a bigger scope project, decided to move on. So when Cisco Joy was released, I was particularly excited because their database were much bigger than all the other sets. So they had a lot more fingerprints, and fun enough, they had the processes, which is which is a much more cool like set of knowledge to correspond. Like correlating network traffic to process names is a lot more fun from a defensive perspective. And so when we pulled their database list, we actually wrote scripts to convert every Cisco Joy fingerprint into a JA fingerprint, JA3. So they're not directly the same. Cisco Joy actually supports Google Grease, which is like an SSL or TLS feature, whereas JA3 doesn't. They just drop Grease. And so if you're going to do this work, it actually takes a little bit of kung fu to extract the right data points from a Joy fingerprint to format it in a JA3 and generate the list. And when we did that, we went from 97% unlabeled to 91% unlabeled. So pretty considerable progress given like one additional data source, but still a lot of unknown. And even in that labeled set, like it's labeled ... with collisions. It isn't just like labeled perfectly. There's obviously going to be collisions and things you have to deal with. And so we kind of leveraged the idea of what they were doing with Cisco Joy with our own data. So this is where you enter data scientist, which I am not. And we have a guy on our team named Lindsay Lack who does fantastic research for us, more in the data engineering, data science space. And he decided to build what's called, he named the JA3 Synergy data set. And basically what he tried to do was correlate HTTP browsing and traffic from the same host to the same locations with SSL traffic that could be related. So essentially he's trying to leverage plain text data, HTTP, to help gain context on encrypted data. So imagine I browse in my web browser to http google.com, right? I'm going to talk to Google, who's then going to redirect me, because they're going to be like, fool, we don't serve anything over HTTP. And so I'm going to have an HTTP out to Google, and then I'm going to immediately be followed with a bunch of HTTPS. But if you're listening on the network, you see both. And you could potentially make a hypothesis, or I would say a fairly strong assumption, that if they're time-bounded, and they're from the same source and dest, and the server name and the cert matches some fuzziness to the passive DNS of the destination, the HTTP, or the host header of the HTTP, then maybe the user agent we saw maps to the JA3 that we saw follow. And so it's wiggly. But it's kind of like you're trying to gain context on your own data. And that was wildly successful. It actually mapped a huge amount of data for us. I don't have the exact percentage because this was older. This was like an older research project, and so I didn't rerun it. But at the time, it was some words up like tens of 20s or 30s of percents. Like it was still less than 50 or more than 50% enabled, but we gained massive contextual visibility mapping user agents to JA3 hashes. In this process, obviously, we could run this all the time. And so that's what we're working on doing now, is getting it set up and running on all our data all the time to be a contextual batch process and provide that. These pictures are kind of fun. They show what we saw. So what you want to see is clusters here to like show there's lots of user agents of similar kind that are associated with a particular JA3. So on the left, you can see we found what looks roughly to be some sort of Microsoft Mac thing. You can see all the different variants and user agents, but they're all pretty much Microsoft application of some kind running on Mac OS X. So that was an interesting little cluster we were able to pick out really easily, like visually. And on the right-hand side, you see, that picture is horrible, but you see New Relic Java agents. And that stuck out, like there were dozens of these New Relic Java user agents that were associated with a little cluster of JA3s. So pretty interesting to be able to tie similarities in user agents to particular fingerprints and cluster. Again, better, but afterwards we're like, are we any closer to finding evil? So I'm like, we're down the data nerd front. Like data is cool and doing correlations is cool, but what does this actually buy us? And so I kind of had a mind context shift where I went from thinking about what a thing is to what a thing does. So like I kind of started down the path just thinking about what are these things. And what I realized was that's cool, but it's going to be very, very difficult to actually find evil. So I need to change my mindset to think about what are these things doing? Like what are these applications actually doing based on the other factors that we can see? And like most things in detection, no approach is mutually exclusive. We should be doing both, and we should be doing them equally as well. And so what else can we focus on? And so we're still working on this. This is research that's ongoing. And as anyone who's worked on like super generic C2 detections know that this will probably never end, that it's a very difficult road to go down. But anytime we look at representative features or statistics by grouping on these different characteristics is really good. So an example, is the application represented by a JA3 and JA3s pair associated with lots of servers and lots of destinations? So can I group by JA3 and JA3s, and how many SNIs are there? How many destination IPs do we see? Do we see one SNI and one destination over 30 days of data? Because if so, like, that's a pretty non-prevalent application in our data set that is particularly interesting. Is the destination or SNI associated with many applications? So like, do we see this IP address, which might be shared hosting? Are there lots of things talking to it? Because if not, it begs the question of like, why not? Like, we have a lot of customers and a lot of data. Like, generally, we see things across more than one. So if you only see it in one, it's usually fun. When was the application, destination, or SNI first seen? Particularly like newly observed JA3s is an absolutely good like place to start your filtering, just because if it's new, it's naturally interesting. I'll be the first one to tell you, like, I hate the concept of pure anomaly detection, where like you surface every anomaly to a user, because I've been in that role of having to triage those anomalies, and they're a lot less anomalous than most people think. They happen every day. The internet is weird, I'm here to tell you, and anomalies are an everyday occurrence. And so, but I do like it as a start, because some malicious things are anomalous. And so it's a decent filter to start with, especially if you're working POC research. Like you want to run it across smaller sets of data and see if you can find some results. And then there's the classical things, like everyone jumps to JA3, but there's a lot of value you can find in just the traditional SSL flow characteristics. So data sizes, destination and source IPs, periodicity, regularity in the data, like distributions, idleness. One of my favorite things to hunt for as an analytics person is idle beacons, because I, as a red teamer, like 5 p.m., sleep 60 minutes, and I'm going to go eat dinner. Right? Like, that was my like process at the end of every adversary day. But like, what does that mean in the data? That means every 60 minutes, plus or minus some jitter, there's a packet, and over the next 10 hours, it's going to be the same thing for 10 straight hours, exactly 60 minutes, roughly, and then data sizes that are like the same. Almost every adversary toolkit has jitter in their sleep intervals, but they don't have jitter in their sizes, byte sizes. So like, everyone thinks that, all the blue teams are finding evil by periodicity, but like, you don't even bother to adjust your size. And so it's like 97 bytes exactly on the same like rough interval. And so idleness is one of my favorite things to hunt for, and you can do that in SSL, whether it's encrypted or not. And then I love certificates. Like almost every red team I see is Let's Encrypt. Like, I'm here, like, very few are paying for it, especially consultants, because they have to pay with a lot of engagements and a lot of volume. So like, why not just register Let's Encrypt? If you go look at like Killswitch GUI, Alex Remdenko's tools, he has like, a lot of scripts to automatically set up servers. Same thing with Jeff Dimick and Steve, who's in the room. On GitHub, they have tools that like help set up servers and infrastructure. Like, a lot of them will have built-in like scripts to automatically register to Let's Encrypt. Like, so it's a good choke point to go look at. Why don't we just start by looking at Let's Encrypt certs? And I like to keep to track these over time and aggregate. So as with any analytics approach, this is what we found in initial approaches. I found security products. I found financial analysts scripting their access to investment sites. I found lots of Tor and more security products. Turns out security products look pretty evil in nature. And so we pretty much see them all the time, and they hit on all our initial detections in analytics. But we also found evil. So in this case, this was a red team that we discovered doing this approach. So we found this JA3s and JA3 pair, and these are all the labels that kind of got applied based on our analytics. So it was a new application in a server. It was on a single host in our environment. It had a single SNI, a single destination, non-prevalent across our customer base. The SNI was only coming from a single host. It was a low-cost cert or issuer. It was young in PDNS, so when we correlated the IP to PDNS, it was young. It was non-prevalent. Like, there was only one PDNS record. Like, just tons of labels that when you look at this, you're like, that is ugly. Like, but as a red teamer, you're not thinking about all these aggregate roll-ups and stats when you deliver your malware. Like, this is, you're not a data guy usually, so you don't think about what you look like in the environment. Fun enough, the domain that was used by the adversary was actually, they had registered it after it expired from a legitimate company. And so if we were just doing certificate stuff or like by name stuff, it would actually look pretty legitimate.
Yeah,
it was a medical provider website that had expired, and they had registered it like a couple weeks after. And it was, when we went and looked at it after the fact, it was hilarious. It was hosted on the Yellow Books. Like this adversary domain was in Yellow Book as associated with a medical provider. But if you looked at the actual hosting characteristics, it stuck out like a sore thumb that like it expired and was re-registered. Moved from Akamai to DigitalOcean, moved from Akamai certs, or no certs to being certed. It moved from Akamai as a register to Namecheap. So pretty fun. So kind of diving in, final thoughts here. I always encourage people, when you see the hype, when you see something new release and advancements in this field, don't stop there. Listen to everything that's being said. Almost many of the things we told you today were in the original JA3 talks. Like the JAs are awesome folks. They understand all these characteristics. They work in detection. But what happened is 90% of what they said, only most people walked away with 5%. And the 5% was, look, SSL fingerprinting finds evil. And so it's really important as technical stewards in this community to not stop there and fully understand the nuances and caveats associated with these technologies and educate about that. It is useful. This talk was not intended to say that fingerprinting is not useful as anything. It's a new idea that needs to continue being explored, particularly in the behavioral front. And I would encourage everyone to be creative in detection in general. Clever blue teamers find the red. So being creative with how you approach it, not just going for the easy low-hanging fruits, has been very valuable for me and my community. At the end of the day, this is a human game. Human defenders defending against human adversaries. And so it's often how you can think of that humanity that gets you that leg up in playing the game. And I like to say it's all a balance. This is a personal rant or pet peeve for me. And with the crowds moving towards like, just find it all behaviorally. It's so easy. Generic is the only way you should be going. It's all a balance, and they're not mutually exclusive. Polarizing approaches have no place in the industry. You should be doing all of it. If I can get an IOC from X vendor and it's associated with AB29 and they reuse that IOC and I don't catch that, like that's negligence. Like now I'm not saying that approach is the only one you should be doing. Quite the contrary. Like it's in 1% of what you should be doing, but it is useful and we can do it all. Technology allows us to scale this approach. And honestly, the more generic you move, the less threat specific you are and a lot more effort it requires in terms of man hours and technology. And so it's really good to find your sweet spot in the balance on this spectrum. This is kind of a pyramid of pain shout out wherever I pay that tax. At this point, I think we're near done on time. So we'll open up for questions if there is time. And if not, we'll certainly be out back. Yeah. Absolutely. Absolutely, yeah. So that is a call out for information or validation. Yeah, I agree with everything you just said. It's configurable. One thing I find interesting, so like I think a lot like that of like, well, why is this useful? Because I can do X and Z. But the reality is that most of the bad guys we see don't do any of that. Yeah, they're just lazy. It's, again, humans versus humans. And so like, what's interesting is when ideas like this come out, so like I'm hoping this talk, I'm gonna go watch all the red team traffic that we see in our environments, and I'm gonna watch all of them disappear, but I'm not gonna watch any of the real bad guys disappear, because they do follow some of this, but every hour they invest in their ops is money they're losing. Real adversaries opt like a much more efficient business than most of the legitimate pen testers and red teamers, and so they make those calls. But yeah, totally agree. I would love to see more research on the red side of like building custom servers to configure these parameters, like or do it in Apache and do it in the different Python server applications and start masquerading, making that more common. It'd be fascinating. That's a good question. It's on the order of thousands, if not higher. I mean, it depends on what specific application. So Cobalt Strike's a really fun example. It uses WinINet underneath the hood. And so anything else that uses WinINet, it looks pretty similar with the difference being Cobalt Strike has a Java server versus a lot of like Apache stuff. But we still see WinINet talking to Java like all the time in our real environments. There's a lot of Java web servers out there, my friends. And so that's one that like has been collision prone that we wanted to use the hunt for. Like we were hoping that that would be a silver bullet on that one because of the malleability. These toolkits that have a lot of malleability, like we were hoping these fingerprintings would be the bullet. But that one has a lot of collisions. Again, scripting languages, they collide on the JA3, but not so much the JA3s. So. ETA being encrypted traffic analytics from Cisco. Yep. Yeah, totally. There's, I mean, there's been research here in the past. I think we've actually spoken in the past, but there's been research here in the past about encrypted traffic analysis and ways to do it. And there's a lot of white paper research out there in this space too, in terms of machine learning and modeling on encrypted traffic. And the slide I did on the behavioral stuff, a lot of that's in there. There are segments that aren't in there, and I would say mixing in applications into those encrypted traffic analytics is still kind of new-ish. Like we're starting to see it in vendor spaces. We're a vendor, but I think there's still a lot of myth around applications and how unique they really are. And so we're seeing a lot of what might not be called false positives, but in the terms of a defender sitting at the keyboard, they're a false positive.
So not much. The essential data for the JA3 fingerprints is still there. You have the TLS version, you have the cipher suites, you have an SNI field potentially, maybe an ESNI.
Yeah.
It's there sometimes. But the core is the same because it's still the cipher suites, still the TLS version, still the elliptic points.
I also think it's fun with 1.3 because it's 1.3 in the spec versus 1.3 in the implementation and what's been seen. And so like I've seen presentations list like 1.3, fingerprinting should be broken. It's not working anymore. But we've seen the JA3 folks will tell you like they've seen supposedly 1.3 where everything was intact, and we've seen it too. And so it's like implementation to spec is always a fun one to look at. But there has been people, there are fields in the spec that could be challenging. I think it's particularly with SNI and the extensions being encrypted. So. Not a lot. Honestly, we've seen very slow 1.3 adoption across our customer base. It's almost all 1.2 still. And so we haven't quite gotten there. We're still, I mean, quite honestly, we're still early in some of the behavioral pieces here. So.
We did do a few tests of 1.3 via the APIs on Windows, but like I said, you still get a JA3 fingerprint in the end.
Yep. Yeah, I mean, JA3, there's multiple scripts, but JA3 on their GitHub actually has a Python script that you feed it a PCAP and it spits out all the JA3 and JA3s it sees.
There's a Wireshark Lua script as well.
Yeah.
Toss that out there.
Yep. Yep. Yeah, totally. Thank you for that. Yeah, we're actually using the bro config, or the bro module, so it's in there. And I think that's it for time. We're going to be out back for the questions, so please join us, and we're happy to talk. Thank you.
That's me. Thank you.
Thank you.